Hello and welcome to the Raspberry Pi tutorial by me, the Raspberry Pi guy, and today I'm going to be showing you how to control motors using your Raspberry Pi. By the end of this video, you'll be able to make a motor spin, understand the Python program behind its movement, and also be able to comprehend some of the concepts involved in this process. But first, let me explain. So the Raspberry Pi is an incredible device in regards to how it can interface with the outside world. It enables you to do some awesome real-world computing through the use of its GPIO pins. For example, we can flash LEDs and get inputs from buttons. However, because the Pi is a low-energy device, it lacks the ability to control power-hungry components, such as motors. And let's face it, motors are arguably the most interesting thing you can control, as they allow you to make robots. So how do we overcome this then? It can be easily remedied with the use of an external power supply and a simple switching device that works as a go-between the Pi and the motor circuit. By controlling this switching device, we control the motor. So let's take a look at what we'll be using to accomplish this on our Raspberry Pi. First off, you'll of course need a Raspberry Pi. In this tutorial, I'm going to be using this shiny new Model B+, but as the first 26 pins are backwards compatible, both the Raspberry Pi Model B and A will work. Make sure that you're using an up-to-date version of Raspbian, as we'll need the Python rpi.gpio library. This is installed on all new builds. Please note that your Pi will need to be connected to the internet. Next, you'll need a DC motor. I'm going to be using this one. You may recognize it as it's a fairly popular Chinese model. I'll link to where you can buy it in the description, as these come with wheels and are perfect for anyone who wants to build their first robot. It's worth noting that this tutorial is for DC motors only, DC standing for direct current. These are ones with two terminals, not servo motors or stepper motors. After that, you'll need a power supply for your specific motor. Make sure that it is appropriate as well. For example, these Chinese motors need around 6 volts of power to operate, and so I'll be using a battery pack with 4 AA batteries. Most suppliers will tell you what voltage you should run your motor at. With this knowledge, you can change your power supply accordingly. Personally, I recommend batteries as they're nice and easy to use, as well as having the benefit of portability. Last but not least, we come to our switching device, this motor controller here. The board is called the Ryantech rPi MCB and is a great way to control up to 2 motors cheaply, neatly and quickly. At the time of creation, they're available to buy both in kit form and ready soldered. The kit costs just £9.49 and I would recommend that as it will allow you to practice your soldering skills. It's worth noting that the kit's available worldwide, and if we take a close look at the board, you'll see that it fits on the Pi nicely. The extended header here means that you can easily access the GPIO pins. Also, make sure that you have a screwdriver handy for the screw terminals located on the MCB. Now let's move on to wiring up our motor. So the first thing that we're going to do is attach the MCB to the Raspberry Pi. In order to do that, grab your Pi. The fact that it is a Model B Plus or just a B is irrelevant. Then place the MCB onto the first 26 pins like so. Make sure that it is nice and secure and firmly in place. Now that we have the motor controller connected to our Pi, let's wire up our motor. As you can see, the MCB has 2 outputs for motor control. This means it can control up to 2 motors in both directions. In this tutorial, we're only going to use one motor, and so we will need to connect that to the screw terminal labelled M1. Grab your screwdriver and undo M1, and then place either terminal of your motor into it and tighten. It does not matter which way round you insert the wires. Give them a small tug when you're finished to check that they are in place properly. Moving on to the power supply. As I discussed before, this needs to be the correct one for your motor, and as my motor is rated at 6 volts, 4 AA batteries will happily suffice. In order to connect this to the board, we need to use the screw terminal labelled VCC2. This is the power input, and you'll notice that there are symbols above it signifying which terminal is positive and negative. Go ahead and unscrew VCC2, and then insert both your positive and negative lead of your power supply into their respective places. Make sure that you get this right. Then tighten and check with a quick tug. And that's it. You now have a single motor wired up to your Raspberry Pi, and it should look something like this. Now that we have everything in order, let's take a look at getting it to move. So boot up your Raspberry Pi and log in. We won't be needing the desktop environment, therefore don't bother typing startx. Today we're going to use Python to control the movement of our motor, and I've made a GitHub repository in order to make it easier for everyone to access the program that we'll be using. So without further ado, let's download that with the command git space clone space https github.com/the-raspberry-pi-guy/motor, and then hit enter. You should see it download like so. If you get an error, then it's most likely due to a problem with your internet connection. After that is finished, let's type ls to list the contents of the directory that we're in. You can see that we now have a new folder called motor. Let's change into it with the command cd motor. Now we're going to need to change into the code subfolder. This is where I've put the Python program for motor control. Do this with the command cd code. If we list the contents of this directory, you'll see a lone program titled motor.py. This is what we'll be using to control our motor. Before I show you how to run it, let's take a quick look at the script. The code's purpose is to spin the motor backwards and forwards for 3 seconds in an infinite loop, and then end the process if it detects a keyboard interrupt. Ignoring the comments, these first 2 lines import both the time and GPIO modules. Without these, we would not be able to use delays or the Pi's pins. Moving on, we come to these 4 lines of text here. These merely set up the pins that we will be using. Motor 1 of the Ryantec MCB is wired up to Broadcom pins 17 and 18, and this is where I define that. Now if we scroll down, you'll see the main body of my program nested in this while loop here. As you can see, to control the motor, I simply need to make either pin 17 or 18 true and the other false. Inverting this option makes the motor change direction. These first 3 lines will make the motor spin one way for 3 seconds, and then after that it will spin the other way for a further 3 seconds, before repeating forever. If I scroll down a little further, you can see that I've added an except clause here that waits for a keyboard interrupt. So what does this do? If you kill the program with Ctrl+C, it makes sure that the motor is off before quitting cleanly. As you can see, this is a very simple program that I encourage you to add to and make your own. Now that we have our motor wired up and understand the Python program, let's actually run it and see what happens. To do this, make sure you are in the code directory like before, and then simply type sudo python motor.py and hit enter. Immediately, you should see your motor start to spin backwards and forwards like this. Once you've had enough of that, then simply hold Ctrl+C on your keyboard and you should see the program cleanly exit like so. And then the motor's movement should cease. And so that is how you control a motor with the Raspberry Pi efficiently and easily using Python. As the Ryantec MCB can control 2 motors, why don't you have a go at building a simple 2-wheeled robot? That's all we have time for, but make sure to check out the links in the description and don't forget to like and subscribe. Thanks for watching, and until next time, bye.